Is automation really rocket science? Or is automation so simple to actually implement within your manufacturing line? Thank you so much for tuning in this morning. Thank you so much for actually making time this morning as well to listen to what we have to share. And we hope by the end of this morning session, you'll be inspired by what Mr. Eddie Fong from Plasform, of what he actually implemented in his manufacturing line. And we hope that you'll be able to also take this opportunity and move forward and actually take up this challenge, and of course maybe implement a smart factory within your manufacturing lines. So this morning will be very interesting, right? So we're in the middle of the welcoming remarks, all right? And after that we'll introduce Mr. Eddie, who will share his successes in going smart, and later on we have Teh Tarik with Dr. Chua. All right. And then of course when the Teh Tarik ends, then we have an Ask Me Anything session. It's something like a Q&A, right? Now, let me first introduce to you who Mr. Eddie Fong is. Now, Mr. Eddie Fong, he possesses a mechanical engineering degree from Monash University and is a graduate diploma in business administration from Swinburne University. He has been in the plastics industry for the past 43 years and specializes in injection molding of engineering plastics. Since joining the Malaysian Plastic Manufacturers Association, MPMA, he has been very active in the areas of organizing international plastic conferences, championing skills, upgrading via TVET, industry academia collaboration, and technology upgrading for the Malaysian plastics industry. He is the current Secretary General of MPMA, chairman of both the Plastics Technical Training Center and the Talent Development Program. His passion is to see the Malaysian plastics industry upgrading itself to be able to keep up with the skills requirements alongside the constant introduction of new technologies and to be competitive in the global arena. Please welcome Mr. Eddie Fong from Plasform.
Thank you, Kenneth, for the kind remarks. Let me introduce you to Plasform a little bit. Plasform was formed in 1991 when I came back from Malaysia. I came back to Malaysia in 1986 actually, but I was helping my brother develop his ice cream business, believe it or not. That was a year of recession where, 1986, sorry, not 1996, 1986, wow, time flies. And I was developing his ice cream business. Money was hard to come by, so we approached a lot of banks, and to cut a long story short, finally we got some money to expand the business, and the business has since quadrupled in the 6 years that I was helping him. Then I decided that, okay, 1991, it was time to start Plasform, because a lot of the stuff that I learned from Australia, 8 years in the industry in Australia, was very relevant. Not only relevant, was about probably 10, 15 years ahead of its time compared to some companies, on the average company in Malaysia. So that's how Plasform started. So what's our vision for Plasform? We want to be among the top injection molders in Malaysia. Please note that carefully, not the top, but among the top. So there's a difference there. So being the top, very hard, I think. Be among the top is slightly easier, but still very hard. I shall explain why later on. So our mission is to grow profitably, of course, to produce a satisfied customer by supplying quality products that give good value. This is the emphasis there, good value. Giving excellent service that exceeds customer requirements, not expectation, customer requirements. We know their requirements, we want to exceed that. But expectations, sometimes they always expect sky high things, so we cannot fulfill the expectation sometimes. Doing better than our competitors, I think that's, it's not just being kiasu, but also being better means like you want to do a little bit better than your competitor to maintain your cutting edge. What are our values? As a Christian, I believe that everything we do, we should honor God, So the other value is to value and develop each employee. And this is where Plasform spends a lot of time training our employees, whether they are operators, technicians, managers, and so on. I still get very hands-on in this. I still give lectures in the company, to our new technicians that come in, our QC people, and so on, to bring them up to date with the latest knowledge of what I have. To treat each person with dignity, I think that's very important. I was talking to Kenneth just now. Today is our company trip day to PD. because the workers have been complaining, boss, we've been locked down for 2 years, cannot go anywhere. So we decided, okay, I'll go to PD for an overnight trip. They're very, very happy. So I'll join them later. They're on the bus now on the way there. So one of the reasons is to actually build the comradeship among the workers, build comradeship not among their own group, but across groups like the QC and production, always loggerheads with each other. QC and the engineering, and engineering and production and so on and so on. So the building that comradeship is very important. Treat each other nice, We have a new platform culture, which I won't share here, but one of the things is to have a joy at work, and respect each other and so on. So there's a lot to say about that, but we'll leave it for another day. Then to act with integrity, I think this is very important. Yeah. So that's platform in a gist, what we believe in, what we want to work for, and so on. So this is a factory layout of the 2 production floors. We are in 4 terrace factories in Kajang. As you can see, there are about 6 machines in one place and another 8 in another. These are the smaller machines. We have 8 of them lined up like this. 6, 1, 2, 3, 4, 5, 6 here. So we have 14 machines altogether, and we have about 40 people in the workforce. Talking about I 4.0, everybody wants to talk about I 4.0. The government pushing I 4.0 like mad. But what is really I 4.0? They come up with these 9 elements. So if you try to do all 9 elements, you're bound to fail because it's too onerous. So at Plasform, what we decided to do is tackle some of the elements. Start small, but tackle some of them. Robotics, I think we've gone into robotics the 1987, second year we started, we bought simple pick and place robots, pneumatic driven and so on, but that's gone into more sophisticated robots, fully programmable servo Cartesian robots, and now we have bought some cobots, which are collaborative robots. Simulation, we've done a bit of that, but very seldom. I think when customer demand to have a perfect product, so we do a bit of mold flow. In fact, I was a mold flow guinea pig back in 1979 in Australia. We went to the founder's house to do all the programming and so on. So that's another story for another day. System integration, yes, you want to integrate, but try to do the basic things first, I think. So the Internet of Things, we are doing that. All our machines now are connected to Wi-Fi and so on, so they can transmit data to a central processor, so that I'll show you a bit of that later. Cybersecurity, not so important for a little company like us, If you want to hack lah, what the heck. Cloud computing, I think sometimes is overemphasized. You don't have to always have cloud computing. If you are a guy traveling between 11 countries, you're always on the move, you still want to see what's going on in your plant, maybe you might want to use cloud computing. But if you're just stationed in 1 or 2 venues, I think your own internal server would be more than adequate. Additive manufacturing, we dabble into that. If a client wants to see a physical part in his hand, we go and get a 3D printer to print it, not on our own, but outside people. Augmented reality, I think that's some years away for Plasform. I don't think it is a necessity. Big data, yes, we are collecting data to sort of being able to collect data and analyze it and so on. You'll see an example of this later. So the most important thing, I think, before you start to do all these things is think about why you want to do it. Okay, what triggered Plasform to do some of the process improvement, to automate and to start I 4.0. I got 10 reasons for that, and this might be common to most of you also. Difficulty in getting foreign workers and local workers also. Local workers are even harder now because of Grab lah, Panda, Food lah, and so on. Difficulty in scheduling and delivery due to absenteeism among local workers. You want to schedule 3 machines to run for 1 client, and 3, 4 operators don't turn up that day. Habis, you have to postpone your schedule. Inconsistencies in the manual process. If you cut a gate or trim a part, using an operator, in the morning shift, it's okay. Afternoon, night shift, then you've got problems, things like that. Rejects caused by handling in the manual process. The more you handle a part, the more rejects you create. Especially some of our parts are mirror finish, So if you scratch it, one tiny scratch, the whole batch gets rejected, and you sort 20,000 pieces is very, very painful. To reduce WIP, because if you automate it and make a complete production cell out of it, if you like, then you have less WIP. Wages rising fast. Not too long to go. I think we will definitely hit minimum wage of 1,500. At the moment, it's 1,002. You see, when it's 600 ringgit minimum wage, there's no incentive to automate, right? You can employ 10 workers and it's only 6,000 a month. But now each worker is worth at least 1,005, minimum wage doesn't bring you workers. So plus the overtime and so on, you'll be paying about 2,005 minimum per worker, per month. So then it makes the ROI a little bit more attractive. But if you go to 1,500 minimum wage, then you have to pay 1,800 for your workers to come in. Then it's even a little bit more attractive, for your ROI. Reduce boredom of operators. Yeah, I think if the guy has to sit at the machine for 60 seconds to wait for the next part to come, he will get bored, she will get bored. So to retain workers better, you better automate, reduce the boredom in the plant. Increase productivity, of course, by downsizing the workforce. If you use automation, then robots don't get moody, they don't get sick. They do need maintenance, but that's like far and few in between. The uncles don't pass away, the aunties don't get sick, the babies don't get sick, they don't need sick leave, annual leave and all that. They just work 7 days a week, most of them. So monitoring the productivity is very important. You want to know how many % of your machines are being used every day, and out of that machine, how many % of the time it is actually running, rather than stopping, changing mold, heating up the mold and all that. So if you have the data, then you can actually monitor that. I'll show you an example of that. Then the other thing is to need to upskill the technical staff. I think with introduction of new technology, you really need to upskill your staff. And the only way to do it is to get all this new technology into your plant. Otherwise, you talk about theory, go to seminar and all that, it just won't work for you, is it? But before you start on all these things, I think one of the basic things you must start with is lean thinking. You heard about lean, from 25, 30 years ago, 40 years ago, the Japanese started this, and then the Western people also push this very hard. But sad to say, a lot of Malaysian factories are still not thinking lean enough, What is lean? Lean is a set of concepts, principles, and tools used to create and deliver the most value from your customer's perspective, while consuming the less resources and fully utilizing the knowledge and skills and the equipment. So fully utilizing the knowledge and skills of your people and the equipment that you have. I think I should add that in. Things to consider before you embark on, all this I4.0 stuff and in adopting all this expensive technology. Number one is financial requirement. Do you have the financial resources? And if not, if you need to borrow, can you borrow? How much can you borrow? Do you go and buy 10, automatic piece of equipment one time, or you start with maybe 2? If 10 is very nice, you have the whole factory set up all automated, but then financially it might kill you, because the repayment per month is 45,000 a month. Then for a small SME like Plasform, we certainly cannot afford that. So we start small. Instead of fitting 10 what do you call it, the cobots, all in the factory to do everything automatically, we buy 1 first, and then 2, and then more. Talent requirements. Have you got enough talents internally? If you are using 25-year-old machines and you've been hand cutting your gates and so on, when you go to automate, you need somebody else who know how to set the robots and so on, right? If you're collecting data, you have to find the right terminals to tap the signal from and so on. So have you got these people, in place? If you don't have, then you might consider externally using what we call a system integrator. A good system integrator is a gem, If you find one, don't let him go. Work with him for the next 5 years, because they are also very hard to come by. The good ones anyway, Tell you a story. When we bought the first cobot, we bought a very expensive cobot called a UR, Universal Robot. What is a cobot? Okay, so for some of you who don't know what's the difference between a robot and a cobot, C-O-B-O-T, is this. A robot is when you set it up, it will go from A, B, C, D and do A, B, C, D, E, F, G, or whatever it is. And because it doesn't understand that people can be hurt, so the robot will just move whatever that's in the way. So if the operator gets in the way, sorry for the operator, he gets knocked over, either the operator breaks or the robot breaks. But a cobot is different. A cobot is what we call a collaborative robot. It is safe for the cobot to work among people because it's got sensors in the axes, the joints. So it's got force sensors and also torque sensors that detect if it hits something, above a certain setting like 2 kilogram or 5 kilogram or 10 kilogram, the thing will stop and it won't move anymore. And it raises the alarm, then you can actually see what knocked it or what it did knock, So it's safe to work with a cobot beside you. But for industrial robot, you have to put guarding around it, so which takes up a lot of space. So if your factory is small and don't have a lot of room, then maybe you should think about a cobot rather than wasting all the space, putting guards and fences around it. So the other thing is training. You might have to send your people for training in order to understand these new technologies. For example, the system integrator that worked with us, he also worked with a cobot supply company. So we had a cobot supply company people coming to train us, but we also hired actually a mechatronics engineer before that, in anticipation that we will need that kind of technical skill. For me to learn it, it will take another 5 years. So for the mechatronics engineer to learn it is 3 weeks. So you pay a bit more, you achieve your goals a bit faster. Yeah. Okay. Acceptance by the existing staff. You might have to change mindsets, before you embark on this automation I 4.0. Plasform, we've been doing that for the last, 6, 7, 8, 10 years, constantly reminding our people that if we keep on doing the same things that we do now, in 5 years' time, we might be out of business, So this is the phrase I always use, whether I'm in Plasform or in MPMA. If we continue to do the things that we're doing now, 5 years later, we might be out of business, okay? So you have to change their mindset. You let them think, oh, now we've got these things. It's not threatening their jobs, it's going to make them even, how shall I say, higher pay, because of productivity and so on. But they have to learn something new also and accept it. Then you talk about buy-in, then you have to wash their brain so that they buy in. If they don't cooperate with you, you can buy all the most expensive equipment. It'll be just a white elephant sitting there in the corner 2 months later, 3 months later, half a year later. Yeah. So then the pace of implementation is important. Can you pull it off in a short time, or can you pull it off at all, So don't do too many things, don't do 10 things at one time. Do 2 at a time, Get the 2 things done. Have a success story, have something to show them, say, look, it worked, come on guys, let's do the next thing, So that's the approach I take. So when we first bought the cobot, everybody looked at me and said, wow, this boss is wasting money, 140,000 for a cobot, which you can buy a Cartesian robot to do, almost, right? Almost, yeah. But then when we actually showed what the cobot can do, 6 months later, then they say, oh, boss, very good at this one, So we started to buy more, even programmable servo Cartesian robots after that, and then another cobot after that. So disruption to production during implementation is also something to consider. When we first want to commission the cobot, it took about 4 days, but we did a lot of preparatory work off-site, off-site. The drawings, the design, and all that was done off-site, not on the machine. So when the whole jig was ready, we plonk it on the machine. Sorry, that's an Australian jargon. How should I say? We plonk it is like we put it on the machine, near the machine. It took about 4 days to commission it because everybody was learning. They're learning about our machine. We are learning about their cobot, you know. And then there's a lot of adjustment. You know, how come this one cannot, this function cannot work? What happened? You know. Then we have to ask the robot supplier, hey, why this function cannot work? We think it should work, and all that took about 4 days. Then unfortunately, the second cobot that we bought took about 2 weeks and a bit. You know, so there's a lot of disruption. That was sorry, I'm not against Chinese products. I think a lot of them are very good. But this is a Chinese cobot. But the thing is, the system integrator that we work with, because they have their own, was not so cluey and so on. So it took about 2 weeks. So the production was interrupted for nearly 2 weeks, and we were tearing our hair because that product, you know, the order increased nearly 3 times. You know. We had 3 machines running, but this one was interrupted. So we were panicky whether, you know, our customer might leave us. You know. So things like that you need to consider. Okay, some of the things you need to do are simple. You know, automation I4.0 is fine, but go back to your basic process. You know, learn your process well, improve your processes first. For example, I'm into injection molding. Yeah, some of the very basic things to improve the process or productivity is, number one, improve cycle time. So what can you do, you know, to improve cycle time? This is speaking, you know, as an injection molder. So improve cycle time by improving cooling. You know, if there are not enough cooling channels in the mold, drill 2 cooling channels in, you know, reduce the cycle time that way. Reduce the dwell times, or the mold opening and stopping for about, you know, 0.8 seconds. You can cut it down to 0.3. You know, you save half a second. Those dwell times of the movement of the molds, the robots, and so on. Eject the parts hotter, you know, when it's possible, of course, you know, to optimize your cycles, your cooling time, because some parts can be ejected a lot hotter than others. So you don't always have to eject parts at 35 degrees C, because that will take a long time to cool the parts down. Yeah, I will show you in an example later how we did that. Optimize your mold movements, you know, instead of closing at 50% speed, you know, for most of the time, the long stroke can close at 85% speed, and then when it comes to near the clamping position, then you can slow it right down, you know, to have the mold protection working and so on. This is injection molding jargon. Modify your molds to run on auto degate, and I shall show you an example of that. Optimize other molding parameters, like even decrease the temperature of the melt, you know, that will save you some cycle time improvement. Okay, this is an example where we automated the degating. This is on the left. Can you see the arrow? Can you see the arrow on the screen? Can you see my arrow on the screen? Yeah, okay. So here you see the edge gates. Okay, these are edge gates. This mold is I don't know, 18 years old. You know, when it was new, we kind of thought, okay lah. The minimum wage was about 600 at time, 550, you know, so you put an operator, cut it like, you know. So as the production volume increased, we said, you cannot afford to, you know, waste the operator just cutting gates like that, you know. So what we did was we changed it to what we call an elephant gate, a banana gate, a bullhorn gate, depending on which school you come from. Those are the 3 names for this type of gate. So when the mold, it's like a sub gate, but it's a particular shape like a bullhorn, you know. So okay, so now the part can eject with the gate severed, cut already, you know. So all you got to do is pick up the runner, and then with the robot, and then throw it into the crusher to, you know, do your online crushing. So that way you save an operator, you know, spending the whole day pulling all these 4 gates apart. Yeah. So that's you know, process improvement. You know, automatic the gate. This one is a picture on how to reduce cycle time. See, we bought okay, to do this you have to buy a very expensive thermal imager. This is an infrared thermal imager. It actually can take a shot of the molding as it comes out of the machine. It will tell you exactly what the highest temperature is. If you look at this thing, it says the highest temperature at this point is 74.92 degrees. I don't know whether the second decimal is required, but never mind. It tells you that. So the sprue is not the hottest part even, you know, this part of the molding is the hottest part, believe it or not. So, and the mold temperature here is 32 degrees. this was running a 65-second cycle, cooling time 45 seconds. Because my operator, my supervisor touched the part and said, wow, boss, still very hot, oh, you know. But I said, okay, ma, still very hot. It's not distorting, right? It's to tolerance, right? Everything is dimensionally okay, appearance okay. Yeah, still okay. So I said, I will challenge you. I said, eject it a lot hotter. He said, how? Cut the cooling time. I said, he said, how? Why? How? Then the part will distort. I said, you do first lah, then you see lah, you know. So we actually finally brought down the cooling time down to 31 seconds. The cycle from 65 became 51.45. Again, don't know how we get the 0.45. So, but you see the temperature then was rising in the part, 89 degrees. But this is a polycarbonate part, so it can eject at 92 degrees sometimes quite happily. No problems with distortion and so on. And the mold is now a lot hotter. From 32 is now 37 degrees. You know, the sprue also got a bit hotter, but no problem. Sprue got hotter, who cares? You know, as long as the part is good, it's good lah. So the exit temperature now, instead of 74 degrees, become 89 degrees. So, but because you can do that, your cycle time is improved by 21%. Okay, so something like that lah. But you have to invest lah in this technology lah. 18,000 ringgit for the thermal imager is a lot of money for a small SME. But we say that if we do it for every job in the plant, your payback will be 6 months or less. You know, so we invested in that about 2 years ago lah. Modes of automation using equipment. Okay, you can go to automation at the next stage of productivity improvement. What can you use? Things like synchronized conveyors. I'll show you a picture and then explain how synchronized conveyors can help you. Programmable Cartesian servo robots. In the old days, we used to use pneumatic robots. Everything is pneumatic driven. Chung, 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 chung. It can only go A, B, C, D, E. That's it, you know. But with a Cartesian robot that is servo control or programmable, you can go A, B, C, D, E, F, G, H, I, J, you know. So you can. The newer they are, the better they are. Even the Chinese robots are coming out with tremendous products, you know, that are actually as good as the Japanese one functionally or even better, but at about half the price. I'm not saying that they are better, but I'm saying that if you want to start a bit cheaper, okay, don't go and buy the most expensive unless you are very confident. I mean, I've got a Japanese robot. If I tell you the name is Yushin, you know, that they will last 22 years. The Chinese robot, I don't know how long they last, but I bought 4 of them, you know, 4, 5 of them now, you know. So, but it's half the price nearly, you know. So let's start with that, you know. Don't go to the most expensive, you know. Then programmable 6-axis robots or cobots. These are Chang'e things, you know. You can do a lot of things. You can do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, you know. So you can program it infinitely almost, you know. And the path they move can be a curve, can be a ellipse, can be all sorts of paths, you know. Whereas your Cartesian is a bit more limited. And the cobots or the robots can move in a spherical space, you know. As long as it's within that spherical space, the robot can reach it. But your Cartesian might not be able to do. Robots and cobots in tandem with ancillary equipment, and I will show you an example with how we use a cobot with a vibrator bowl and so on to assemble parts. So I'll show you examples of this now. This is a synchronized conveyor. So instead of having a conveyor running continuously, you know, bringing the part to the operator who sits there and then cut the gate or pack or whatever, you can actually synchronize the conveyor to line up maybe up to 10, 15 parts, you know, depending on how big your parts are, along the conveyors. Why is that good? Because then you can have 3 conveyors in this same kind of configuration where they are lining up all the parts. So it takes maybe 10 minutes from the conveyor to get from that point to where the operator's table is. So what happens is, instead of, and your process only takes maybe 30 seconds. So your operator can come back every 5 minutes, you know, to clear the conveyor and, you know, go to the next machine, clear that conveyor, go to the next machine and clear that conveyor and come back. So now you are using an operator to guard, to look after 2 or 3 machines instead of just 1 machine. And the added bonus to that is that your operator doesn't get so bored, sitting there waiting 60 seconds. This is a long cycle part. So sitting there 90 seconds for this particular part, because very thick, it's 3.5 mm, 4 mm, polycarbonate. So therefore, the operator will less bored. Let me put this guy on hold. Sorry. Hey, I'm in a webinar. Cannot. I'm in a webinar. You can call me back an hour later, please. Thanks. Where were we? Okay, so your operator can jaga 2 machines or 3 machines. So you save how many percent? If you jaga 2 machines instead of 1, 50% labor saving. If you jaga 3 machines instead of 1, 60% labor saving. Very good, Cartesian robot, servo Cartesian robot, in this case programmable. See what it does? Stop the part. Opposite to a cut it, throw away the runner. This is the simplest one. I'm showing you so that we don't and wait for the next cycle. Somebody asked me why your robot travels so slow. I say, okay, if it's out of the mode already, it's on time. Going in and out must be fast. It's waiting for the mode to close and do all those things. And the long cycle means that the robot has got plenty of time. You don't need to wear your robot down. Take its time, go slowly. It's still waiting. Okay. This one is just a simple pick out gate cutting force. One cabin. This one is now the cobot from China. It's called a dobot, D-O-B-O-T. Don't know why they call it a dobot. It is taking out. That's what it can do. But let me show you something before. For all this automatic operation, you need to be careful because these are all machines that, even though the robot has a sensor, it won't hurt anybody, but it might still crash into your mold. So you have to set up some safety. What we have here is this machine is, I don't know, 15 years old. We're retrofitting it on a of all brands, Haiti and the China machine. China and China, they can talk to each other. So no wars among them. So we put a light curtain here, so that if the cobot or dobot is in anywhere near the mold inside, the mold will not close. Things like that. You got to put a bit of safety in it. So that one also is another thing that you have to learn, that because if you start on this without the safety, you might damage a very expensive. This is 80,000, worth of equipment. Oops. Yeah. So next one is we are using this. This is a Danish a cobot, which is from Universal Robots. This is very, very, very expensive. 140,000 to set up this fellow with a bit of the jigging, but not this. This one is another, don't know, 15, 18,000. I forgot already. So what we are doing is we are trying to assemble this part, this little part here called a plug to the big cap here, the blue one. It says the test run. Yeah, so that's what you can do with a cobot lah, or a industrial robot also can do. But this one, because our space is limited, like I say, it's open. You see, you don't see a guard around it, so it's safe to work with people around it. Okay, then we found that it can do so many things. So we say, why don't we try something new with this? We make it into a milling machine and see what happens. Does it work or not? So this doing a milling operation. Is following a contour track into the original position. And the operator looks up the next one, and it can start again. The story of this part is that we have a problem with the molding. The molding is about 30 or so microns over the thickness. Why? The technician go and pack the pressure so high that the thickness actually increased by about 30 microns. So it's 30 microns off spec. So we said, wow, we throw away 6,000 pieces, 6,000 pieces is 9,000 over ringgit, So we said, since we've got this the cobot, why don't we try to salvage that 9,000 ringgit, So we actually bought a what do you call it, a servo motor here, speed control motor, some make up a table, for it and so on. So the whole thing costs, including the labor, 2,000 ringgit or less to actually do all the milling, do all the setup and so on. So if you do the sums right, you say 9,500 minus 2,000, you save 7,500 ringgit worth of products, So that was quite a good payback, if you like, for a cheap investment into a speed control motor like this. So you can do that with sophisticated equipment. So in fact, if you really think about it, you can use your imagination to do a lot more with something like a cobot. Okay, this is a vision sensor system we install on the mold to detect parts. After the mold has opened and ejected, make sure that all the parts are cleared before we clamp it again. So yeah, you saw a flash, right? About there, I think about you see the only thing you can see is the flash up there. It's now taken a picture and then compare it to the master that you set up. When you take a picture of the master, the mold is clean, there's no part stuck in it. Now, this is a typical shot of the Cognex system where this part is put in there on purpose so that actually to simulate that there's a part stuck in there. So the mold doesn't close now because the sensor say that, hey, there's a part stuck in there, better not close the mold. This is going to cause double clamping and damage the mold and so on. So if you've got very sensitive molds and very high precision molds, this is the way to go. Otherwise, you clamp the mold once, it's going to cost you 2,000 ringgit maybe. Wiley will be able to tell you that some of these high precision molds take a lot of fixing, And not only that, you incur the wrath of the customer and disrupt his production for 2 weeks and so on. He's not going to be very happy. So if you've got a sensor system like this, it will report to you. It says result here, fail for that particular mold. Fail means the part is stuck in the mold like this, and the detection will prevent any mold damage. So that will save you money and a lot of anxiety and a lot of sleepless night. So, okay, data collection system, we want to see whether the machine is running or stop. You want to compare the actual cycle to the costed cycle, calculate efficiency of the run, shows any disruption and stoppages during the run. We can add things like setup time, purging time, startup time, all into the data, so that at the end of the week or the end of the month, you can analyze it and see how your machine is performing, how your shop floor is performing. This is a typical dashboard that we took, this is around the 11th of this month, earlier on. You can see that, there's a machine identification here. You can see in this part, the targeted cycle is 39.5. The actual running cycle is 38.95. So this machine is running at about 102% efficiency. That tells you that the day shift has produced so many parts and the night shift has produced so many parts and so on. So if the line is straight on the top there, then there's no interruption. The machine is running fine. But look at the bottom part, machine 10, cycle is a bit over cycle, but not too bad. You know, about 4% out. No, 0.5. It's about 2% out. So there's some interruption here, you know, as you can see, which the line is down here, then there's interruption, the machine has stopped. So you can see during the day, about 2:15 like that to about 3 o'clock, there's a lot of there's a long interruption here, and then start again, and then another long interruption. So you can point this bubble at anywhere along the line, and it tells you exactly when the interruption started. Then with this data, you can go and talk to your supervisor or your technician and say, hey, what happened to the machine at 2:15? You know, there was an interruption. Or then they tell you a long story lah, you know, the part got stuck lah, like this lah, or the material got stuck in the throat lah, didn't come down lah, or whatever, because you're using regrind and so on. So but the gist of it is that you can now see, you know, whether it's running well or not. And then you can ask those questions and then find out the causes. And then from there, you can take some steps to fix those problems and get rid of them. So this is the usefulness of data collection. This is only calculating the efficiency of the machine. So you need another 2 variables. You need also the uptime of your machine, available time of your machine. Then the other variable you need is to see your quality yield, whether your 100% of your parts are good or 85% of your parts. So if you multiply the 3, you know, 0.9, 0.9, 0.9, for example, you get 72% efficiency. Most SMEs run at about 45 to about 55% efficiency, if that. World-class company, they're approaching about 80, I think 85. So we really want to move on to become world-class, you know, in Malaysia. So this is the reason why we are doing all these things. I think that's about it. Sorry, I've taken a lot more time than I intend to, but I thought I'll explain a little bit more so that, you know, we don't rush through. Thanks, Kenneth. Back to you.
Thank you, Eddie. Thank you. Thank you so much, Eddie. Before we proceed further with the Teh Tarik session, right? So Dr. Chua actually apologizes because he had to run. He had to go for a family emergency this morning.
Oh,
right? So
not good. Huh?
Yeah. Nowadays, everything is very interesting and very impromptu, actually. Yeah. I think the other day when we had a discussion, right, we had all kinds of, not say manpower problems. So we got manpower issues, we got annual leave. And then what I like was interestingly now is we have COVID leave as well, you know. Yeah. What I'll do is I will take over the role from Dr. Chua here for a short moment in time. All right. Then we open the session for some Q&A. All right. So that eventually, if any of you out there, if you have any questions, please write it down. Or if you're comfortable, if you are not comfortable asking via Zoom, you can type it here in the chat box. All right. I'll put it up here. If you are comfortable talking through Zoom, you're not very shy, so you can unmute yourself, of course. Introduce yourself, please, and of course, ask your question away. Yeah. Now, so before we continue with the AMA, I've got a few questions on my side. All right. So for Eddie, I think it's very interesting, Eddie, that you have really for Plasform, right, for an SME, as you mentioned, that you have already implemented a lot of automated processes. All right, like from your synchronized conveyors all the way down to your robots and cobots, of course, and of course, which is working in tandem with some of the ancillary equipment. All right. Now, in terms of talent, all right, you mentioned as well that you also needed to get some buy-in as well from not only from the existing staff, but I would assume as well that because you already bought into the whole topic of talent development, right? How do you manage to actually engage with your staff as well, or engage the whole company to actually buy into this whole topic of going smart or going or adopting automation in this case?
Okay. Yeah, I think about 7, 8 years ago, MPMA had a program, a pilot project with a company called iPlaso, where we actually had training courses in injection molding, scientific molding, smart manufacturing, smart maintenance, and lean, you know. So one of the things I was very determined to do was to send them on the lean course, you know. So if they understand lean, this was 8 years ago, I think 2014, yeah, 2014, 2015, about that. So lean, when they came back after lean, you know, still like not so convinced. Okay, you know, we implement a bit here, a bit there, a bit there. But I have to drive it. You know, being a small company is easy for me. I can, 1 minute I'm down the shop floor and walking around doing my Gemba walk, and I can pull them up and say, hey, look, come here, look at this thing, you know, it's not doing right, it's not doing right. So it took many years. It took about 5 years before we actually, you know, went sort of heavy into that, because you really have to have the buy-in, like, you know, you look at the faces when you talk to them and they're not convinced, you know. But then you do one thing for them. Okay, you say, okay, let's do this, do one small exercise, you know. And I don't know, Malaysians are probably you know, in general, slow learners, you know. Some of them are very quick, but my people are a bit slow. So it took me a longer time. So I did some improvement for them and said, let's do this. Okay, then at the end of the month, you know, we've done that. We say, see, now, you know, you save some operator time, you save this, you save some. I said, and then I calculate for them. Okay, we save, you know, $600 this month. I said, that goes toward your salary increase or your bonus at the end of the year.
Oh.
So if you want more, then do more. So for many years, we were doing that, And then automating the gate cutting process and so on. That is a no-brainer. I mean, you know, if you can modify the mold to do it, we've done it for about 10, 15 molds already now. Over the last 6, 7 years, I guess. There are a lot more examples I can show you, but due to lack of time, I can't do. So you slowly condition their mind. You show them a small success, then they say, hey, yeah, it makes sense. This boss is not trying to make us work hard only. It's now working smarter, you know. I say eventually, if you do all these things, then your job will be a lot easier. You don't have to go down and shout at the operator, why don't you cut it better? Why you cause reject and all that. 6 meetings later, you know, we still, you know, writing a report on what's the root cause of the problem to our customer and all that. All that time wasted will be saved, you know, if you can do it right. You know? So like that, I think, Kenneth. So yeah, talk to them, talk to your people. They are people after all. They have a heart. They have emotions, you know. Puji them a bit or praise them a bit when it's done. Yeah, see, well, you did a good job here, man. I mean, you know, we save 600 ringgit a month on this. So it's a journey, it's not something you can do straight away and get success, you know, overnight.
Yeah. So I like that 600 ringgit. So ladies and gentlemen, so you know what to do, right? So you can tell your operators, sorry, don't quote Eddie though, but you can actually tell them, so you save 600 ringgit, can go to your salary increment maybe in the future. Yeah. Fantastic. There's also something I think which was very interesting that you also shared earlier, right? About because you spoke very much about talent as well, and you believe very much in training in this case, right? So I understand that you're also a customer of SHRTC under for the Malaysian Smart Factory program. Do you see any value coming out of it?
Yeah, I think what Dr. Chua was doing was to started a course on data collection and analysis and so on. So our mechatronics engineer, we have already employed our mechatronics engineer, Victor. So I said to Victor, hey, Victor, why don't you go and attend this course, you know? There are 4 blocks, I think, block 1, block 2, block 4, if I remember correctly. So for Victor, he's quite well exposed to this. I also, did I send another guy, one of our technicians also to do the course? So Victor did course 1, and I think he said, oh, boss, I think I can manage by myself. I said, fine, you know, because you got a degree in mechatronics, so it's okay for you. But the other fellow needs to go through it, you know. So after training, they found out a few things that, you know, and of course, then Dr. Chua was very good. He allowed Victor to call him any one time you want to call me, I know, and ask almost like free consultation, which I was very appreciative. So Victor had a lot of exchanges with Dr. Chua and decided, what system to use, the node rate system
Right. That's right.
being used to form the dashboard and so on. So from then on, we say, okay, we get a system integrator to buy us the equipment, because they know how to find all these things. So we actually did that, and we wanted to do it on 10 machines under grant from MIDA, sorry. But MIDA, unfortunately, their approving committee only gave us 1 out of 10 for a system. So we say, never mind, we bite the bullet, we pay for the other 9. We get the 110 also, all right, because we want to do it anyway. It's not because MIDA has the grant we want to do. We want to do it in the first place. So the training was very useful. The guys then understood, what data collection was about, how you can use it, and so on. So from then on, we just tinker and experimented, and I gave Victor quite a free hand, didn't peer over his shoulder all the time. So he enjoyed the work. But let me caution you on this. Not every mechatronics engineer is like this. You have to find somebody who is willing to go hands-on. Okay. Victor was climbing ladder, doing the wiring, and do all this, connecting the connectors and all that. So I found him very good at that because he was tinkering around with electronic things as a hobby. If you can find a guy like that, take him. No good having a guy who is so afraid to touch the tools and touch the machine and all that. No, that won't work for you. You need the guy who is a little bit more hands-on, who's a bit more rugged, who's and in even our technicians, I got 2 technicians who came from the culinary background. So because the school was suspended because of no fund, the parents came to see me and said, "Boss, can you take my son?" 2 of them. I said, "Wow, your son culinary, and they know how to cook only. They don't know how to do machines, right?" They said, "But they are willing to learn." I said, "Okay, what are their hobbies, at home, Oh, they say they love to tinker with their motorbikes." I said, "Wow, okay, that's good." I was like that, I tinker with everything. So I said, "Okay, we'll start them." And today, 2.5 years later, they are our technicians setting up machines, robots, cobots, doing more touch-ups and so on. So I think you need to get hands-on people who has a propensity to learn, who is willing to get their hands dirty a little bit. Those are the very useful ones to you.
Thank you so much, Eddie. It's very inspiring to hear that you actually managed to get a few. Well, you got 2 culinary students, so maybe they're cooking something for you differently now.
No, they only did it for one semester, one term.
Okay. No problem, don't worry. So you mentioned something about data collection as well, right? And the dashboards as well. And you mentioned, I think, in one of your presentation earlier, for machine 9 and 10, right, that you actually use data to actually maybe investigate what the downtimes were. Would there be any other references that you made during this time, or do you do only for these 2 machines or any other machines as well?
Oh, no. Now we have it done for 1, 2, 3, 8 machines already. I mean, I cannot show you all 8.
Sure.
We just showed you the 2. It's a typical dashboard. I showed you 2 typical ones. One is running very smoothly and one is interrupted. There are worse ones than the second one, when sometimes we see a lot of interruption. Because 1 or 2 processes, 1 or 2 machines still run on fully manual because of problems with the mold. It's an up and away core, and they get stuck to the up and away ejector. So our robots are not strong enough to grab it and shake it and pull it out. So we still run a couple of machines fully manual. And when you see those, your heart also saying, "Ayo, why is it running 75 seconds instead of 65 seconds?" And you've lost productivity there. So we are taking steps also in those modes to actually go back to the customer, because many of our modes are supplied by the customer, and say, "Look, let's fix the mold," and we offer a lot of free consultation that way, to help the customer to fix the mold. In other words, indirectly helping ourselves. Yeah. So no, we've done it on 8 machines already, and we're still waiting for some electronic parts because of the global shortage of supply of electronic components. The parts have just arrived, at our system integrator's place. We are asking him to assemble it into a box so that we can wire it up and by the beginning of next month, we should have all 14 machines on the data collection system.
Cool. Thank you so much. Thank you so much, Eddie. So let me just check on the chat to see whether you've got any questions. So ladies and gentlemen, if you have any questions, you can please ask around, right? Pafma, is it?
Yeah, I have one interesting question. So Eddie,
Yes.
I'm more focused on the solution delivery offering to company like you and other SME manufacturers. So I'm not a manufacturer. I'm not focusing on only on my operation. So what I noted is your knowledge depth on both your core domain of plastic injection or precision plastic injection, admirable. You've been here for many years, but the knowledge that you have on technology element like cobot. I mean, very few CEOs that of SMEs or owners of SMEs that I saw that are able to talk on all the jargons that you just spoken. This is our domain. This is my domain. I would say like node rate, like Wi-Fi, like security issues, like cobot, 6-axis, servo. All these are our domain expertise, where you as a CEOs were quite enlightened. And I think because of that enlightenment, you're able to implement so many innovative solutions into your organization. But my question to you is this: how many other SMEs are in that kind of top management of SMEs are in that kind of realm, and how they address this? Because the same week, this week, I had a session with FMM members, and many of the top management people pointed to be that because they depend on consultants or they depend on system integrators, and system integrators will consultants tend to bias to what they are preferred or know or have, and then they will limit the information flow, and their ultimate motive is to get the sales closed, like get the PO. I mean, I'll be honest to you, the ultimate motive is that, honestly. So they will tend to cut corners or whatever, and end of the day, 10 out of implementation or projects, 8 of them will become white elephant or dead halfway. So how you think the top management should look into this, and how people like us, the service providers, the technology providers, can bridge the gap and to make sure they're successful? Because believe me, sir, if you guys are not successful in implementing these things, we won't grow. Both of us won't grow. It's the spiral, everybody will go down the drain eventually.
Okay, good point you made, Padma. How do you make them? I think the Chinese say that you can bring a horse to the pond, but you very hard to make him to drink the water. So I say, first of all, the CEO of companies who are in charge of all this automation thing, they have to educate themselves. I have the privilege of being the technical reference person for MPMA in one aspect. So I've been organizing technical seminars, international conferences. We used to have every year, alternate years rather, a technical conference with the VDMA. VDMA is the German manufacturers of equipment and so on. So I'm exposed to all the latest technology equipment due to that, not that I've learned it all, but I know what they are capable of doing and so on. So I think CEOs have to at least learn these things, but who is to educate them? This is the problem. If you as a company, Padma, you go and educate the whole of Malaysia, you go bankrupt before you earn your first dollar. So who else then can educate them? The government is trying to emphasize, but by the same token, they cannot educate the CEOs. So I think the best people to do it will be the associations that they belong to. In MPMA, I've been pushing this for the last, I don't know, roughly 20 years. So because of that, I forced myself to learn. Because if I want to tell somebody a story, I have to know it, right? I have to. So I forced myself to learn all these things. And by the way, I got a mechanical engineering degree to start with. So that helped a bit. And the business administration graduate diploma, that also helped on the business side, the ROI, the financing, the cash flow, etc. So how do you make people learn it if they're from, a lot of the old bosses are standard Form 5 graduates, but there are those that have learned it very well. And I know one of the past presidents of MPMA, he's only a Form 5 boy, he said, but he's learned it very well. He's the president of the mid-tier consortium of companies, So yeah, so this continuous lifelong learning thing, it must be a culture for all the CEOs. But now you cannot afford to learn slowly. That is the problem. You have to accelerate your learning. I think that, you know, by attending seminars, like I think Plastic, somebody is from Plastic. I think Dato' Noraini is one of them that is very keen, always learning. She's the CEO of Plastic, but she's always keen to learn. In seminars like this, and it's even free some more, you know, I mean, today we are so privileged. We can get hold of so many seminars, so many videos on YouTube, so many searches. You can go on Google to find all the technical information, you know, but you must dedicate that time rather than watch a Korean drama, you know, during the evenings. I stay up until 10, 11 o'clock almost every night. If I'm not watching the football, I'm doing something for MPMA, going through the WhatsApp, YouTube, and learning some things like, you know. Yeah, I think that has to be part of our learning culture. Otherwise, how do you learn? You have to accelerate your learning, like I said, because the world is moving so fast that if you don't accelerate your learning, you'll be left far behind. You know?
That's right.
And then the other thing is you need to synthesize all the things that you've learned, to synthesize it, you know. For example, the cobot can do so many things, but I don't think anybody has used a cobot on an injection molding machine yet in Malaysia, you know. They use it on CNC machining centers and so on. I know that, but in Malaysia, I think Plasform is probably the first one to use a cobot.
So far, the first one I saw.
Huh?
So far, the first one I saw.
No, I think it's the first one. I asked the cobot supplier also. Have you seen anybody using it on in a machine? No, because the cobot is 140,000. My old machine, 16 or 15-year-old, is only worth probably about 20,000. You know, they say, "Wow, I buy a Rolls Royce to put it on a Proton. I cannot." You know, so the mentality is that no, I must buy new and all that. No, you don't need to. You can retrofit it if you know what to do, you know. And that machine that I show you with the robot one has been running since the pandemic, 2 years, almost non-stop, 7 days. We only recently we run 6 days now, you know, because of slowdown and so on. Yeah, so the lifelong learning culture must be stressed, lah.
Let me just continue with another follow-up question. The question that you were talking about, the money issue. As I told you, I've connected to a lot of SMEs as well. And like what you put it as now, buying a Rolls Royce to retrofit it into a kanche. And when you want to compare the Rolls Royce price to the worker's salary per year or per annum or whatever, so when you do that, your ROI looks tremendously long. And then plus with the recent pandemic slowdown in the supply chain issue, your downstream and upstream, that demotivate the SMEs to further invest their time or energy on 4.0 alike. So how you will advise the SMEs to look beyond that kind of mentality?
Okay, you have to know how to do your sums right, lah. Of course, you have to go through the financial sums. When we first bought our cobot, we sort of look at it this way. Okay, the sums don't fit in very well. If I have my way, 2-year payback is my maximum I want to target for, you know. But the cobot took 3.5 years, you know. Okay, if you calculate it on how many operators you save, you know. But I say to myself, okay, I bite the bullet. 3.5 years is not good, but we can learn something new here. We can expose our people to a new technology which they have never seen before, you know, working in the plant. They've never seen it in any seminar in Malaysia yet on injection molding. And I have future plans in mind. I said, no, we not only stop at using it at the injection machine to just pick up parts and cut parts. That one is any servo robot, Cartesian one at 1/3 the price, 1/4 of the price can do. But we're saying that, okay, we use it as a learning tool. And I've done it many times when I bought machines, you know, 15, 20 years ago when I bought a machine with a graph, you know, plot a graph that show you the injection pressure inside the mold and so on. There was no payback, in fact, because the customers don't want to use that. They say, wow, I installed the device into my mold, it cost me 4,000 ringgit more. You know, why I want to pay 4,000 ringgit more? But I bought the whole system, 50,000 plus the sensors, you know, what we call pressure cavity sensors. So if you put one is 2,000 ringgit, if you put two is 4,000 ringgit. So I show my people, because in theory we can see in the class, or the graph goes out like that, like that, like that. But now I can demonstrate it. I can show to them on the machine. This is the graph that your lecturer told you. This is what you see here, and this is actually happening in the machine. Then they have a very good idea. Oh, really? You know what we're learning is not a bluff. It's so things like that, you know. So sometimes you have to buy things. You bite the bullet. You as a learning, as tuition fee, if I may call it that, you know, so that your people can go on to the next thing, you know, and they're inspired. They're inspired. I mean, after seeing the cobot working, they say, "Oh, boss, ini banyak canggih." I say, yeah, banyak canggih. Tapi wang pun banyak canggih. Tapi I said, never mind, we all learn it so that we can do other things with it. You know?
Can I add on? Hello, it's YLU here, yes.
Yes,
Can I add on to the earlier point, Pakma asking about the whether SME got CEO to look at what we are talking about today. Actually, Eddie Fong himself is a very good example of what an MD or CEO of a SME should do. You know, the main point here is that whether it's a small company or medium-sized company, or whether you are using older machines or new machines, you know, whether you may not need to be really very highly good financial resources to do it. You can do it in step-by-step basis. But the main thing here is that, you see, when I say Eddie Fong is become the good example, is because you have to come from the top. You see, you don't have the board of directors or the MD or the CEO to lead the way. Then down below, I don't think you have your engineer, your managers able to follow, you see, to advise you what to do. But sometimes the commitment from the top people are the number one important. Otherwise, your next thing is getting difficult to move. That's why I say Mr. Eddie Fong is an example, because he is leading the way all the way for the last 10 years. You see, that's why I'm saying he can move on. Whether you use 6-axis machine, 5-axis or 3-axis, right? So therefore, those are the commitment. I think in our plastic industry, my observation is that there are many companies, their bosses, their shareholders, or even the board of directors, they may not like to commit a lot on making changes. If the board don't make the changes, how do you expect the employees to change their mindset? So I think this is one of the most important part of the steps. They must come from a top down, you know. You see, last time when I engaged the consultant for ISO, I thought ISO earlier days was so difficult. You know, ISO 9001, wow, a lot, very tedious. So the consultant tell me, as long as the top are committed, push the thing down, then the rest will have to follow. So that's why I'm saying, so the commitment from the top is very important. If you want to have a plan to go into automation or I 4.0, I believe that to begin with, the commitment from the top management or even the board of directors, then you're able to move on. So this is my small bit of sharing of my opinions.
Yes.
So how the things go.
Thank you so much, Mr. Liu. Thank you so much, Eddie. Yeah, it seems like it's now very interesting. So with Plasma here as well. So it looks like it's as you know, in summary, right? I think from what Eddie and of course Mr. Liu shared is very much a top-down approach. And then after, I would say top-down. So it's a top-down approach. It means the bosses will have to take control, also to take the lead in this case, all right? And then get the buy-in from all their staff. Look, this is what we want to do, and let's do it together. And then you have to show, I suppose in this case, right, the advantages of, say, for example, if we go towards or actually implement a 4.0 or smart process within a small segment of the whole manufacturing line, then I think everybody will understand why the company or the boss is trying to move towards or moving forward kind of thing, all right?
Yeah. There's a question here, Kenneth.
Yes.
Aisha asked the question, how do you know that your people are ready? Can I answer that question?
Sure, please do.
This is a very tricky question, Aisha. Aisha, show us your face. Where are you? Then I can talk to you face to face. Okay, can you? Okay,
actually, my video is not working.
Oh, never mind. Okay, I know you're there. All right. So it's this, Aisha. The first question you should ask is, yeah. Okay, great. The video is working now. The first question you should ask is your top management ready? Not whether your people are ready. But why contribute very, very clearly? Your top management must be ready. Number one. If your management is ready, then is your top management really ready to go through the mill, go through the heartache, go through the experience of failure while you are implementing some of it, 12 years ago, we bought a servo Cartesian robot, okay? And that was 80,000 ringgit. Years ago. 15 years ago, actually. So it was a Japanese Yushin robot. So we wanted to use it to automate this, then automate that, and automate that. So after using it for about 2 years that the project ran, the people were lazy to actually use the servo Cartesian. It's a programmable, but today they are even more programmable. Those days it was almost the Rolls Royce of machines also, So we used that for 2 years and found that the people are lazy. Every time I ask them, hey, why is that one not running automatic? Is it don't have the time to fix up the end of arm this the attachment and all that to make it run automatic. So then I realized that okay, my people are not ready, but I am ready. But how the heck do I go and push my enthusiasm or induce them into this enthusiastic mood about do something try because they are scared of failure also. The first project was I was doing it and with the robot supplier, it was a success, but when they come their turn to do it, I realized that they didn't do it because they were afraid to fail. They didn't have enough training. We just bought the very chunky equipment and plonk it on, the robot supplier did everything, is running, everybody is happy. Oh, we got a servo robot running. But they were not sufficiently trained. So therefore, I realized that, okay, we need to get our people into training. So when the talent development program came in 2014, I believe, so we sent our people for training, massive training, 200 hours of training for 3 of them. And I also went for 50 hours of training. Another QC lady went for 50 hours of training. So we had something like, 700 hours of training for SME over a period of like almost 9 months. The plant was running on autopilot. Why? Because our factory manager was in training, our chief supervisor was in training, the managing director was in training, the QC head was on training. I don't know how we survived that period. We were out the plant more than we were in the plant. So that was the pain that we had to go through. So, okay, fast forward now, 2022. We had 2020, I think 2018, we decided that, okay, it's time to, after that heavy training, it's time to embark on more automation, lean, and things like that. So we begin to buy, like why I say, you don't do all, for the whole plant, you financially, we cannot hack it. So we do 2 at a time. We bought the first Chinese servo robot on a new machine, and then we bought another one, then we bought 2 more, and then we bought the cobot. So like that, and then we also started the data collection system. We also done the automatic assembly. It's still the one you saw where the cobot was assembling the thing to the blue cap was just a mock-up. So eventually it will go into the machine, pick up the 4 parts and assemble it just like what you saw. It is a journey, Aisha. It's not something you can do within 2 months. It took us about 10, 12 years, you know. So, I mean, like I say, we are slow learners at Plasform. So if you got somebody who is more dedicated to do it, a manager that is very passionate to do it, MD is helping him, giving him the support, you know, you know, it takes years for you. I think Kevin asked, Fatma asked, how many SMEs are doing this? Fatma, I think maybe 3% of SMEs are doing what I'm doing. I think, like, you know, from my general talking to people and so on. I'm talking about SMEs. I'm not talking about multinational companies or mid-tier companies. So it is rather a slow journey for us, for our industry.
Thank you so much, Eddie. Aisha, do you want to add on something? I hope you answered the question. Sorry, Ken. You raised your hands earlier, so can you ask your questions, please?
Yeah. Actually,
Sorry.
yeah.
Sorry, go ahead. Go ahead, Aisha.
Okay, because I'm currently the one who lead. Yeah. Can you hear me?
Yeah.
Okay. Okay, because I'm currently the one that will lead the team towards the digitalization. So when I go down to the process, manufacturing process, I feel like the basic manufacturing process is still not in place. So yeah, I just want to know like how long it will take for me, and I need to plan by stages, right, to make it work towards that way. So that's why I want to know how to make them ready towards these directions because I need to start initiate this kind of thinking in them, to set this mindset in them. So yeah, it's kind of challenging, but yeah, I have to do it.
Yeah, don't worry. I think in Dr. Chua's words, right? So not even Dr. Chua. So I think for all the SMEs here as well. So a lot of them mentioned that I think it's one step at a time. So not only, I think Eddie also mentioned about managing expectations of your office clients, you know.
Yeah.
So for Aisha, you need to manage expectations not only on the client's perspective, but on your boss's perspective as well.
Yeah.
So it's like a one step at a time approach now in this case, because I think even for like Eddie in some of his journey towards automating certain lines, right? He also took one step at a time kind of thing.
Yeah.
So I think that's sort of like the best method so far from what I've heard and from what I've seen so far.
Get in touch with like-minded people, get in touch with system integrators, get in touch with trainers. Aisha, if you give me your contact, I can point you out to, say, somebody who trains on lean. You know, Mr. T is very good on lean. So you might want to talk to him and see whether he has a course running on lean. So I think that's the good starting point. When you understand lean, then you begin to think, wow, I can save so much here, save so much there, save so much there if I do this. So it's a two-step thing. You understand your lean, you think about how you want to implement your lean, then afterwards you automate. Because it's like this: if you have a bad process and the process is not robust means you are making a process that is the temperature go up and down by 5 degrees, no problem. The process will still make good parts. If my material vary in the property by 2 or 3 degrees, then 2 or 3%, then still my injection molding machine will still produce the good part. If my hydraulic temperature is up, down 3 degrees, I still will produce a good part. That is your operating window, is wider, you know. So you have a robust process in that sense, you know. If your operating window is so tiny that you move 1 degree, 1% out here, 1% is out, you know, you're making reject part, then you don't have a robust process. Now, understand what is a robust process for your particular company. Talk to the people who understand lean. That's step number 2. Number 3, it's because if you make things very efficient, run a 20-second cycle. So what's the point if you're running a 25% reject at 20-second cycle? You might as well run it at 30-second cycle and make 99% good parts, or even better, 100% good parts. You understand? So don't go for efficiency unless you got robustness. You know, this is my approach now. Make your process robust. any variation, no problem. 7 days a week, I can run 100%. It might be slower, it might be 3% slower than my neighbor, but he's running 10% reject, I'm running at 100% good part. So like this lah. And then after that, you get in touch with the right people who can teach you a little bit more about what to do and so on. That's when you need to get system integrators and good suppliers first, good brands, good suppliers that meet your need. You don't need I think the UR people will be very angry with me. You don't need a UR for every job, yeah. You can buy a small Cartesian for many jobs and so on. But I bought the UR because it is so adaptable. You can make it do anything, like you can make it do milling, assembly. You can make it knock at things. You can make it punch hole. You can, drill holes and so on. We're going to use it for other milling operation where it grabs the part now and offer it to a milling cutter that is stationary. And then it just mills the part, it can move in this elliptical fashion and so on. So that will be the next level of sophistication that we want to use the UR. So everything has its cost lah. You get what you pay for lah, in a sense. Yeah.
Thank you, Eddie. So Ken, sorry for keeping you waiting, but I think you better ask a question away, please.
Hey, good afternoon, everyone. I'm Ken from Pauline Industry. We are located in Prai, Penang. Thanks, Eddie, for the kind sharing. And I think what Eddie was sharing was actually quite a very down-to-earth, classic SME example. I think we all are facing the same kind of challenges and trying to look for a good alternative to make our business grow, and also transforming our so-called non-so-sexy industry. I think some of us are here from second generation. I get a chance to meet with Mr. Liu 5 years ago during a trip in Germany. We actually went to visit some very jungle Industrial 4.0 factory. There was a factory we visited in Germany that is doing just one product, which is this wall plug. Okay, they have 96 injection machine, and everything is fully automated. They only have 6 engineers. So that leads to me. I think I have 2 questions for Eddie. First one, I like to know is when you engage into this journey, how many engineers do you start up this program? All right, that's my first question. And of course, the second question is always the challenge, right? Like, what kind of challenges are we facing when we start implementing this? Because during my era, like 4 or 5 years ago, we also get in touch with those who are in lean manufacturing, and Universal Robotics is one of the first one to come in Malaysia for cobots. I was actually looking at the other robots called Rethink Robotics from Boston in USA. Those are the cobots as well. So the challenges I'm facing the most is we know, I think most of the bosses or the CEOs knows why we need that and reason why we need that. But the problem is, how are we going to make our team, all right, to know why these changes or this transformation will help them? This is my challenge. So I'm hoping maybe Eddie can share with us a few of this. Thank you.
Okay, thanks, Ken. Great question. Let me go one step back. I think going to K-Fair and going to these international exhibitions are a great way to get some inspiration for any CEO. You must be sincere. I know a lot of people go to K-Fair just to eat the pork knuckles, and all that in Germany, and drink the beer, and go to the European tour after that, after the K-Fair. But when I go to K-Fair, I spend 4 days in K-Fair. I come back straight away and jot down some notes and say, okay, these are the things I want to do in the next 3 years before the next K-Fair. So that is a mindset again. How many engineers did I start with? I was the only qualified engineers in Plasform for the last 40 years. Okay, before we employed a mechatronics engineer. Now, during my time though, I've sent my factory manager, who was a Form 5.5, Form 6. He didn't finish his Form 6, to a management course called production management. I've sent my accountant to a MBA course, and sponsored him, for an MBA course, but he's left us, young people sometimes. So I have sent my people are probably among the most trained in injection molding and its related technology, mold making and so on. Per capita, if you like, we're only a small company now. At the moment, we have 40 people. So 2 years ago, I employed this mechatronics engineer because I thought he would be a key person in implementing all this. Because I don't have time, again, when you're running a business like mine, SME, you have to know everything. You have to do everything. The government liaison, and top of them, I've got MPMA duties as a SecGen and the chairman of this committee, that committee, and so on. So 20% of my time is spent in MPMA. So I said to myself, I cannot do it. I'll die, before I get a heart attack before I can finish implementing all this. So I needed help, So I bit the bullet, and it was quite expensive. I paid better than average, much better than average pay for a young graduate, fresh out of TAR college. But I saw the potential in him because he tinkers with this and that, amplifiers and guitars and microphones and electrical devices, Wi-Fi devices, and so on. So during the interview, I asked him a lot of questions, and he seemed to be the sort of guy that I need, hands-on, very much hands-on. Don't mind getting his hands dirty, climb the ladder, come down, use power tools to do this, make up a jig to do some experiment on this, cutting this, cutting that. So great guy, So we only have 2 engineers, but the ratio of technical people to the process worker has increased. So for every 3 operators that we don't need now, we got 1 more technician like that, So you need more technicians now, so because all these things are technicians' job, to set up the robot, to so on. So our factory manager, who is non-technical in nature because he's with me for so many years, 32 years, he has also picked up a lot of things along the way. So now he can make end-of-arm attachments, pneumatic things, cutters and all that. He can make an arrangement. So in our cobot, we have a quick coupler, We bought a very expensive quick coupler. The coupler itself is worth 8,000 ringgit, I think. Okay, it consists of a male and a female. So the I don't know which one is on the machine. I think the male one is on the machine. So the female one. So you prepare this jig here and so on, this end of arm attachment. All you need to do is couple it on top like that. 10 minutes, you're done. If you use the traditional method of taking the whole thing out and then screw it back, together, it will be an hour, So is 8,000 ringgit, 10,000 ringgit worth what you pay for in a coupler? It depends on what you value, If you value time and convenience and interesting job and so on, because it's very lechy for the technician to go and strip the thing down and cannibalize something and then fix it back 2 hours later, you waste the time. Excuse me, I just need to put this on hold. Mei, I'm still on the webinar. I call you back in half an hour. Oh, okay, thanks. So sometimes we bite the bullet and buy all this expensive thing. Why? Because we feel that in future, I think empowering your people, make the life of your people easier, more interesting, is worth more money than the savings you save on all these gadgets, So now all our robots, we have these couplers now, the new ones that we bought. The old one don't have this sort of thing, But the new one, even the servo Cartesian, we have a quick coupler. It's again 2,000 ringgit for that one because that one got less attachments. With the cobot one, it's got pneumatic ports, it's got electrical connectors all in this head. So when you connect it, all the electricals are connected. The pneumatic is connected, so that you got 16 output, 16 input, and all that all connected with one click, a bayonet mounting. So you don't have to go and rewire 16 points and all that. I mean, that saves an hour and a half. I think it's worth it. If you do a lot of more changes, over the next 1 year, then it will save you that 8, 9, 10,000 ringgit. Yeah, you had a question following that. I forgot what.
The second question was asking about the challenges, the most tough challenges? You mentioned about the engineer that you have, but what is the most challenges, things that to make your team to be aware into this transformation?
Oh, okay, I think that phase is over for us. Now our people see all the things that we've done in the last 4 or 5 years. They are totally buy-in. The other day, I bought a 600 ringgit rack to put all this end of arm attachment. Usually my people will tell me, boss, no need to buy, so expensive, you know, we can make one ourselves and all that. I said, no. If I buy 600 ringgit tomorrow, you can use it already. So we have now a lot of end of arm attachment for the robots and the cobot. So I have a rack that is 10 by 10. So got 20 attachments I can put it. I bought a glass door one, you know. Then he said, wow, boss, why you buy glass door? I said, glass door so that you can see what's inside. If not, you got to open the cabinet. You look 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't know which one you want. I say at the glass door, before you open, you see, that's the one I want. You know, open the door, you get that one. So you save 1 minute maybe. We also bought a labeling machine, just to label all the shelves. Cost 150 bucks. I think my plant manager bought it to label each shelf, so that they know exactly what to put where. You know, things like that. This is part of 5S, you know. So you do your 5S, you do your lean. The most challenging is to get the mindset change. That was like 8, 9 years ago when we, you know, our first programmable robot wasn't utilized enough at all. You know, 80,000 ringgit worth of equipment. You use it like a normal pneumatic Cartesian robot, you know, which cost 20,000, 4 times the price. So, but that phase is over. So the psychological how should I say, change in your people. The boss has to drive that, you know, and the boss has to be a die-hard kind of, you know, how should I say, a sucker for punishment. You know, you talk about it every week. Oh, by the way, we have a team meeting every month to talk about these things, you know. So I introduce new things in the team meeting. I say, next month we are going to think about buying this thing. It can do this. I show them a video. Sometimes I sketch it out. Sometimes I inspire them by whatever means I can, you know. There are a lot of videos nowadays you can go and get from the internet, you know, what a robot can do and so on. So whatever you want, I think you can get from the internet. 8, 9 years ago was not so easy. So yeah, so you have to do that constantly do it, you know, week after week, you know, until they have a buy-in. But you have to have some small success. If you implement it, you got 1 or 2 jobs that, hey, wow, then you know, I have a bad habit of spending money. My wife said, why you spend so much money? We go and celebrate. After one success, I take it out for a decent lunch, you know, which they normally won't afford themselves. My technicians, my factory manager, my chief supervisor, and so on. We go and blow 400 bucks on 6 of us, you know, to buy them a decent lunch, and they're all very happy, and then they remember that, and then they move on to the next one like that. So it's a journey.
Thank you, Eddie. Sorry, ladies and gentlemen, unfortunately, fortunately or unfortunately, all right, I enjoy the conversations coming on. Thank you so much, Ken, for your questions. Thank you so much to YA Liu and of course Pafma as well earlier for the questions as well. I know it's running a bit late. I promised everybody that we should finish about 12. All right, we've overrun quite a bit, but conversations was great. I didn't want to stop it as well. There's a bit of advertisement from my side before we close off, and then we'll ask Eddie to maybe give a shout out, right? Let me share one screen with you guys first, sorry. So for, I think Jessica was mentioning somewhere in the chat about Rise Forward, right? So for any of you who are already applied or still not have applied yet, or if you have an RA report, right? And you want to apply for Rise Forward, please do so. The deadlines were closed, I think, sometime February, but it's still open for the meantime. So if you've got any opportunity to apply this Rise Forward grant directly with HRD Corp, please do so, all right? If you're not sure about whether you are qualified or not qualified, as long as you have an RA report, no, we can actually assist you in applying for this grant, all right, directly from HRD Corp. Now, let me give you one last bit here. Okay, so just one last thing. So we thank you as well for signing up as well, for coming up this morning as well. All right. So if you don't mind, so we have a YouTube channel as well that we actually do over from let's say mid of last year until today. And along the course of this period, right? So after having discussions with Eddie, and of course previously with Mr. Long and all our other speakers as well. So there are two QR codes here. One of course is the YouTube, all right. That we normally do is what we record, and then of course we put it online, and then you can actually review it if you wish, right? Then we also have on the other side, which is actually the checklist. Now there's a lot of questions about, you know, how do we move forward, whether is my plant ready, or is my manufacturing line ready, or is my factory ready, or if there's team management, all right, or whether is the team ready, or do we need buy-in from the management as well, or from the staff, or is it bottom-up approach or top-down approach? All right, so in this checklist, so Dr. Choi and I, we sat down together one day and let's just do something like a quick checklist. So the checklist is not hard and fast rule whether you are ready or not ready. If you're not ready, then basically in short, you know where to get yourselves ready in this case, all right? But if you are ready and you want to embark on getting, say, for example, smart processes within your manufacturing line, please do so. All right. Please contact us as well today. All right. And thank you very much for all your time, gentlemen. Eddie, let me stop sharing. Sorry, I want to thank MPMA as well for supporting this quick sharing as well with everybody as well. I think Wendy and Sujata are here. Thank you very much, Wendy and Sujata. And of course, Eddie from MPMA, who's the Secretary General. For Eddie, before we close off this afternoon, and then everybody can go for their lunch, do you have a quick shout out for the audience here about how do they take that first step to digital, or well, in this case, digital transformation?
Yeah, I think one of the things you need to do is, you know, Dr. Choi has got a course on the data collection and digital transformation. So get in touch with Dr. Choi of HRDC. He's not here on the screen now. Maybe Kenneth, you can.
You can contact me.
Yeah, you can contact Kenneth, and so that would be one aspect of it. On the robotics side, I think you need to talk to people like maybe me and people who've done it. Kite, I think, has bought some robots. You know, some of our MPMA members in the north have got robots and so on. I'm talking about industrial robots and you know, servo robots and things like that. There are many people who have got servo robots. When you come up to talk about this industrial robot 6-axis one, a few less a few of them, you know, not many. So talk to them, which is a good brand. The normal good brands are the big brands, the UR, the KUKA, the German ones, you know. If you want to talk about just Cartesian robots, then Yushin. The Chinese ones are not bad, you know. If you private message me, I can point out to you one that is, I think, good value for money, which I am using. And also, you know, Whitman, you know, some of the German ones, but beware, German ones, they're all double the price. So it depends on what you want. If you want a proven thing, you want a super speed robot, then you have to go for the European ones. They are high speed and so on. But if you're like me doing 35-second cycles, why do you need a high speed robot? Anyway, you know, you can take your time. The robot, once it's out of the mold, really pick up from the mold, in and out of the mold, you need to be fast. Once it's out of the mold, you know, you can just go for a casual walk and offer it to the station, because your cycle is 35 seconds, you know. If you are doing a 6-7 second cycle, then you need a super fast robot. You need those. Yeah, what else can I say? The cobots, unfortunately, they are not as fast as the industrial robots. So you need to be aware of that, because they have to move slower for safety reasons. So they move quite slow, you know, like that. With the industrial robot, if you go whoop, whoop, like that, you know, but the cobots cannot like that, you know. So be aware of that. If you do a 6-second cycle, then of course the cobot is not for you. It's something else. If you do a 10-second cycle, sometimes you might be able to approach the cobot, but usually 20-second cycles kind of thing, you know, if you want a rough idea of what is suitable. yeah, then a good system integrator is also very important after you've got the equipment. When you come to install all this data collection, I think you need to have a technician that knows how to tell the people who supply the equipment. For example, if Dr. Chua recommend you somebody to fix the thing on for you at your plant, your technician must be able to tell him, hey, where is the tap point for the mold opening, or the mold fully closed, or mold the ejector fully forward, or the ejector fully back. Those kind of things are basic that you need to know. If you don't know even that, then society, then at least you have a diagram, you know, your machine maintenance machine diagram to tell you the circuit and say, oh, this is the point. And then of course the old machine, sometimes they don't mark those points properly, right? So you still don't know which one. After you've seen the diagram, is B1, but where is B1 in the, when you open the cabinet, mana itu B1, tak ada. Then a bit susah already. You have to do a bit of trial and error. You might burn a circuit, you know, when you poke the wire into the wrong place. Those are the things you need to look out for. But unless your machines are like 15, 20 years and older, most newer machines have got them pretty well marked up, right? Unless you're buying a second-hand machine from somewhere, the people have stripped it all out, then susah also lah. So not all machines can be retrofitted, but most can, like, yeah.
Thank you so much.
Does that answer the question? I don't know, Kevin.
I think in summary of what you have shared, yes.
Okay.
Right. Thank you so much, Eddie. So any from Mr. Liu, do you want to say anything extra, or?
Why? Is he still there?
Yeah, I see him, but he's on mute though.
He's muted. Why?
Yeah, nothing. It's okay. I think I have to say thank you to Mr. Eddie Fong. You know, you are very generous to share your information, your ideas. So
we are getting to the age where, you know, I might have to retire, you know. I don't know how many years later, but
yeah,
I can't take it to the grave with me. So
yeah, you and me about the same. All right. So we have been nearly 40 years of experience in injection molding. So
it's a waste if some of the knowledge that I have and people don't have, it goes with me when I retire. So while I'm still active in MPMA and not retired yet, I thought I'll share. Okay, you can catch up with me and you become my competitor. It's okay. I mean, you know, the world is big enough for 3 of us, you know, rather than just 2 of us. I say it like that. So if you become my competitor, there are only 2 of us. You know, if another guy also does the same, there are only 3 of us. So I think the world can fit in 3 of us.
Good. Fantastic. Thank you so much, ladies and gentlemen. Thank you so much, Eddie. Thank you so much, Mr. Liu, again, for your kind words as well. And thank you so much. Please stay safe. Yeah, I heard there's many interesting cases out there. All right. Thank you very much, ladies and gentlemen.
Okay.
Have a nice day.
Thank you. Stay safe. Stay healthy.
Thanks for organizing.
Thank you,
everyone
thank you for your time.
for spending the time to listen in. Thanks.